Okay, folks, this is stats. This is the second half of 2-4, where we're talking about scatter plots, and I'm recording this a little bit different because I want to show you how to go into Google Sheets and get, I know you've done this before in like Mr. Moose class about like graphing a scatter plot using data. I know that you've done that before, but I am going to show you how to have that then spit out an equation for you, and also give your value of r. Like it will calculate the value of r for you to tell whether these two x and y are linearly correlated or not. Okay, so I'll show you how to do that. And then I'm also going to, at the end, for those of you who have a graphing calculator that looks like this, I will show you how to do that on your graphing calculator as well. So some of you guys can tune out if you don't want to listen to that. I'll tell you when you can stop listening, but we'll go through that as well. Okay, so here we go. All right, we stopped yesterday, and of course I'm on my different computer, so I don't have all our notes and everything that we had before, but we stopped yesterday talking about values of r and how r, oof, this is going to be real rough, how values of r live between -1 and 1, right? So -1, +1, 0 is considered to be a bad value of r. That means he does not have a linear correlation. This is considered good, whoop, and this is considered good. Don't judge my handwriting right now. I'm like typing with a mouse pad or a trackpad. It's not working very well. So good values of r live over here and over here. Bad values of r live in the middle at 0. Okay, now sometimes, and I'll show you how this works on, especially on the graphing calculator, sometimes it will spit out a value, what's called r squared, okay? And r squared is just this value squared, right? So 0.591 was the value of r that they gave us for this data set. They said, here it was. And we said that when I have 5 numbers or 5 groups of data, he has to be at least a 0.878 in order to be considered a good linear relationship. So 0.591 is not a good linear relationship. R squared, a lot of times, if I take that number, 0.591, and I square it, it gives me 0.349, let's say, okay? And another way of thinking about an r squared is this number will tell you basically what percentage of your data follows a linear relationship. So here we're only at about 35% of our data is following a linear relationship, which is not great. Like if you get a 35% on a test, you're like, well, I did really bad, right? And that makes sense because this is a bad linear relationship, right? It has to be a 0.878 in order to be considered good. So 35% is not a good percentage, but sometimes instead of giving you r, they will give you r squared. And we'll show you over here that that's kind of how that does that, okay? This, I'm going to show you how to do a regression line, or what's called a line of best fit, and it will spit out an equation that looks similar to this. The only thing that I don't like about this is usually linear functions are y, y equals mx plus b, right? Where m is the slope and b is the y-intercept. Hopefully you remember that from like algebra and algebra 2. But in this case, it's b plus mx, right? It's like the opposite way. So just be careful. The m is actually this guy here, and the b is the b naught. So whatever, doesn't matter. That's just kind of how that equation's set up. But you are probably more familiar with mx plus b. Okay, regression line. All right, here we go. We are going to take this data up here and we are going to put it into a spreadsheet. If you want to go ahead and do that also on your Chromebook, or whatever computer it is that you are using, you can practice this as well. You might just have to pause this video. But if you want to go through this, I went ahead and to save time, I typed in, usually your first row will be your x's and your second row will be your y's. That's just kind of a general consensus. They usually always do that. They will tell you if it's not that way, right? So x is the top row, y is the bottom row, or kind of like in, if I make my columns go like columns instead of rows, the first column will be x, the second column will be y. All right, so I've typed these in here. I'm going to highlight those, and then I think there's a button you can push over here to insert a chart, but I'm going to go insert, and I'm going to go chart right here, insert chart, and it is automatically, I think, giving me a scatter chart. I could choose any of these other charts if I wanted to, but that's what I want, is a scatter chart, or a scatter plot, as we call them. And then I want to go over to this customize button. Okay, I want it to give me the equation for that y equals mx plus b equation that represents how these dots are. So I'm going to go series. Am I going to go series? Yes. I'm going to go to the series button right here, and I'm going to go down to where it says trend line, and it's going to insert a trend line. So this is the line of best fit, or a trend line. So it's saying if this would follow a linear pattern, this line is going to be the closest to all of those dots, basically. The closest linear function that's going to be the closest to all of those dots, all right? And the computer does that, and we can talk later about how it goes about choosing those dots, or choosing that line. But it just wants to be closest to all of the dots and all of that stuff, okay? Now I want an equation, right, for this pattern. So what I'm going to do is I'm going to go to down here right here where it says label. Right now it says none. I want to use equation, okay? And so what it does here is in the top, kind of like this whatever area right below the chart title, it gives me that equation, all right? I'm going to write that down over here. I'm going to scoot over so I can see, and bear with me. Somewhere you can put him, let's put him at the top of the second page, all right? We have y equals 1.73 x. I'm really bad at this trackpad, but whatever. Write this down on the top of your paper. Plus 125. I have to use my eyeballs to see that I can tell if there's a decimal there or not. Okay, so that is my equation. Now, what is x and y? Y is your height and your x is your shoe print length. So maybe it's beneficial for you to go height. So I'm going to change this to an h. I'm going to write an h over top of it. And then I'm going to call this s. Okay, now, why is this equation helpful? If I know my shoe print length, I can type in, or I can punch in my shoe print length, or my not shoe size. There's a difference between shoe size and shoe print length, right? Shoe size is, like different for everybody, because sometimes people like their shoes tighter. Some people like more room in their shoes, right? Like whatever. So they go shoe print length. That's actually measuring the length of your foot. Kind of like when we collected data, we actually measured the length. I think Carter was the one doing this, right? Measuring the length of feet versus giving me your shoe size, like a size 9 or whatever, right? Shoe print length, all right? So if I know my shoe print length, I can plug that in here and it will tell me my approximate height of what I should be, okay? And again, this is in centimeters, so you can't plug it in inches, but that's how that works, all right? So this is the equation that it is spitting out. Now, if I go to, I'm going to go back over here, and I go to show r squared, it will right next to that equation show me what the r squared value is, which is 0.35. Guess what? That's exactly what they said over here, 0.349. That's exactly what it was. Now, let's say I have my r squared, but I don't have an r. They're giving me that r squared, they're giving me r squared is 0.35, but they don't tell me what r is, right? I want to know what r is. I know that 35% of my data is following a linear function, right? That's what r squared tells me, but how do I find r? It's just math. You take the square root, right? So the square root of 0.35, and actually the square root of 0.349 is going to give me closer, is going to give me that 0.591, right? So that will better help me figure out whether it is a linear relationship or not. How fancy. You probably knew how to do a scatter chart already, just because Muth, I think, has you do those with measurements that you do in boiling water, whatever you're talking about, right? But adding those other elements in there is helpful also. The line of best fit equation and the r squared value that tells you how close that linear relationship is. Good. Perfect. All right, let's go down here. What they did was, in this last example, they did a regression line, but instead of taking just these 5 data values, they took the whole data set, okay? You guys don't have a textbook. There is a textbook that goes along with this class. We just don't use it. But in the back of that textbook has not just not just 5 of these, but it has like a whole big data set that has shoe print length and height, okay? And in that data set, there are 40 pairs of data in the whole data set, not just the snippet of it that you got in that last example. 40 pairs of data. So they did this to all 40 pairs of data, and they said, here is the equation that it spit out. So it's a little bit different than the equation that we got, obviously, because we have 40 pairs of data instead of just 5, right? We've got a lot more to go off of. Notice that they switched these two around, so they did b plus mx instead of mx plus b. Whatever, just be careful. Shoe print length is like my x over here, height is like my y coordinate over here. But this is what they got when they did all 40 pieces of data, okay? Now, when they did that, they said that your, do they say where r is? I don't see it up there, but they, in their like data crunching, this is another software called StatDisk, that is possible to use instead of like putting it on a Google Sheet or whatever. I think StatDisk you have to pay for though. But anyway, the correlation coefficient R, don't worry about this other stuff right here. We'll learn that later on in the year. But the correlation coefficient R for this is 0.8129. R equals 0.8129. Oh, look at that. Okay, 0.8129. I'm taking forever to draw this, sorry. 0.8129, we'll just go 4 decimal places, right? That is a much better R than the R that I got when I only had 5 data points, right? This is a much more linearly correlated, right? Not perfect, not 1, but 0.81 is decent, right? And what is considered acceptable? Well, now we have 40 pairs of data, and 12 pairs of data is only requiring that I be 0.576 for a critical value of R, right? So that is definitely higher above. And this is showing that yes, if I use all 40 pieces of data, I do in fact have a linear correlation between the two. How fancy. So there is how that works, all right? So again, they used a different software than we did, and they used all 40 pairs of data, but, and these are the 40 dots or 40 pairs of data. Line of best fit. But anyway, that's how that works, okay? All right, this is using, so if you are, I'm done giving you notes now. If you do not have a graphing calculator like this one, then you can probably tune out at this point and go and work on your homework assignment. You should, I think yesterday I gave you number 4, 5, and 6. Do 7 and 8. Okay, so you should be able to have the whole homework assignment done for Monday. All right, here is how you use this graphing calculator to spit out the same information as what we did over here. Okay, so here's the deal. One of the first things that I want to do is I want to go, and you see where it says stat plot right here above the y equals. I'm going to go second y equals, and I'm going to turn this first plot on, okay? So notice how this is black over top of the 1. I'm going to hit enter, and I'm going to, it's right now off, I'm going to hit enter again, so it's going to switch it from off to on, right? You saw a little switch over there, okay? All right, so now my stat plot is on. If I go second y equals again, it'll see my plot is on, all right? If you're ever to a screen where you're, you don't want to be there anymore, you can go second mode or second quit. What color is that? Blue color, and mode, and then it will take you back to the main screen. So I have my plots on. My scatter plot is turned on. It will give me a scatter plot now. Great, except it won't because I don't have any data in there. So the next thing I'm going to do is I'm going to go to stat, and I go to stat, and it's hovered over top of, it's blackened out for edit. I'm going to hit enter because I want to edit, okay? If you have stuff in your L1 and L2, you can go in and individually clear those out, or you can go up to the top and make the L1 black, and you can hit this clear button, and you can hit enter, and it will clear out your whole column at once. Same thing for L2. Go up and hover over L2, hit clear, and hit enter, and now everything's cleared out, okay? I'm going to, give me a moment, I'm going to enter my data in. So I'm just going to enter these 5 in. So L1 is going to be, and this takes forever, I'm sorry. L1 is going to be my x-axis, so 29.7. Okay, if you want to enter this in also, you just go right ahead. Actually, I would kind of encourage it. Do this and see if you get the same result as me. 31.4. I'll stop talking out loud because that's really annoying. Okay, that's my last data point. So now I'm going to go over to L2 and I'm going to enter my numbers in here. 175.3. I said I wasn't going to do that. Sorry. And I hope I typed all those in right. I'm going to check myself here. I'm getting blind though, so I've got to really hold the computer screen up to me. That looks okay, I think. All right, so all my data is in there on L1 and L2. Okay, now what I want to do first is let's graph this data and see if it what it looks like. So I'm going to just hit the graph button. Why not? Okay, nothing's showing up. Crap. So, and there's a reason for that. I knew that was going to happen. If you go to your window button, your x-axis is going -10 to 10. Look at my x's. My x's start at, my lowest x is 27. So I'm going to go on the x-axis. I'm going to start with 25, and I'm going to go up to, let's say, 35, whatever. Okay. My y values, my minimum y value, my lowest y value is 172. So let's go 170. And let's go 190 for my highest y value. Okay. Now if we go graph again, there they are. Right, there's all my 5 data points. Still doesn't really look like a very good linear correlation. Whatever, it'll be fine. All right. Now I've graphed it. I can see all of the things. Now I want it to make me the equation. All right. So I go back to stat. And I go, instead of going stat edit, which is where all my data is, I hit the over button, so it's hovered over top of the word calc. And then I go down to linreg, which means linear regression in the form of ax plus b or mx plus b. Linreg, linear regression. I'm going to hit enter. And it's asking, do your x's want to come from list 1, like you typed them in? Do your y's want to come from list 2? Yes, I do. I do want them to come from those lists. You can have different lists if you want to. If you type those into the different list column, that's totally fine. But I'm going to go down to calculate. And it's going to spit out an equation for me. And it spits out ax plus b. So I have 1.73 and b is 125. Hey, look at that. 1.73 and b is 125. How about that? All right. Now, the last thing is I want it to spit out my R value. Okay. It should, and some of you guys already did, if you're on this screen, some of your R values might have come already across down here. If they don't, this is how you get them, and you will never have to do this again unless you reset your calculator, but this is how you get it. You have to go to the catalog button. So you go second catalog, all right, which is second 0, and I'm going to go down to diagnostic on. So I have to, these are in alphabetical order. I'm going to go down to D. Diagnostic on. Right there. Diagnostic off and diagnostic on. I want to be diagnostic on. I'm going to hit enter. I'm going to hit enter again, and it's going to say done. So now I'm going to go back to stat, over to calc, down to linreg. I'm going to go down to calculate. That was a lot of steps. We're just going to the same spot. Now I have an R squared and I have an R value. So again, your R squared was 0.35 and your R value was 0.591. How about that? How fancy. So calculator will do the same thing as what your Google Sheets will do. If you need to go back through and watch this again, because I kind of went through those steps on your calculator really fast, you just go right ahead. But that is how you get that information, all right? Now, the nice thing is I don't think I actually had you do that from scratch on any of the problems for your homework, but it's a good thing to know, and we will do that later on. I will actually have you do it on a calculator later on. So just be prepared for that. Nice things to know. Now, if Mr. Muth has you do that for, do like a regression line or anything like that for that, you know how. So that's fancy. All right. Okay, that is it for today, and we have a nice long weekend. So happy 4-day weekend, and I'll see you Monday.